So obviously I'm here playing the role, so I'm going to be a little bit more offensive about Max than it's probably to my heart, so just forgive me for antagonizing people like that. For the people who are in my ISD1 class, Max is obviously a great product and we love every minute of working with it. Let's just clear that up as well. Anyway, so I'm going to talk to you about ChucK. ChucK's a product of Go Wang's PhD thesis research based in Princeton. He's now in Stanford. That's the kind of introduction. He kind of developed the language and was involved in the development of the environment that I'm going to show you working in today. There you go. That's just so you're aware. It's not kind of my work isn't this code. I'm just showing you this code sort of stuff. So let's just clear that up kind of nicely. So I've used Max since it was on OS 9. Had a kind of from before that I've been working in pure C, and Max was Max made doing music really easy, because doing music when you're starting with C isn't very much fun. You spend weeks and then you get the MIDI notes in and then you still haven't made any noise, but at least you know. Whereas Max does that stuff really quick, so that's where I liked Max. I started to get annoyed with Max more and more recently for a variety of issues. The timing issue, and I don't just mean that in the snobby Max timing is always wrong. I just mean in the general sort of time in Max is a really kind of weird thing. If you may remember, I know there's now the global transport system in Max 5, but in Max 4 there was a transport object, wasn't there? Can you remember what it was called? Was it transport as well? But it never worked. Yeah, I don't know if you remember.
The timeline thing.
You know what I mean? Timeline. It was there. I think it had a section in the reference, didn't it? And it didn't work, and nobody used it for anything. And that really kind of threw the kind of work I like to do. We love to joke about messy patching, and that is, for me, that's the kind of big Max thing. It always looks messy. You can obviously try object-oriented stuff, heavily abstracted approaches, and presentation mode makes it a lot better now, but it's still nonetheless, you always end up with that horrific patch cords going between places. Also conceptually, I think it's really messy because there's there's no separation between this is DSP and this is kind of control data processing. It's all kind of on the screen sprawling together with kind of patch cords. You get the different color cords and stuff, but it's still all kind of sprawled around the screen, which I think can really disguise and overcomplicate a lot of stuff that you're interested in, because you're looking at a patch and you might be interested in the DSP side of it, but there's so much kind of control data sprawling as well. It's going to explode. So there's all.
It'll switch off in a second.
Yeah, it'll do it every 20
It's just
minutes.
heating
I
the
want to touch
water.
it though.
It's the end of the talk. Thank you. Sorry.
But they're really distractions against my number one dislike of Max, which was just all this global, the fact that everything's global by default, and you kind of want to use a send and receive, and you're right, you use a send and receive because you don't want to use patch cords, because patch cords are horrible and messy. And then I started building more and more big things, but always out of little elements. I have a very kind of abstracted idea in my mind of how Max should work. So I'd build a little sampler, build a little synth, and I'd always be having to check that my send and receives weren't kind of cross-pollinating against each other, and you can obviously use the #0 argument to try and solve some of those problems for you, but then you go from having a send and receive, which makes perfect sense to you because it would be called audio out, to audio out with some random number at the end of it. And if you want to try and dynamically pull something together, you've got to work out what the receive argument you need is, and this sort of stuff. So I didn't think it was particularly neat. And then obviously the buffers do this and all this stuff, and it just winds me up more and more. So I've mentioned the logic DSP integration, but the big thing that always bugged me is that in Max I always find I'm coding out problems. I'll build a patch, it kind of works, and then something breaks, and I have to build it again. And then I decide I want to change something. And I know the stuff that Alex has been talking about would probably simplify some of that, but I've been at that situation where I've had a control pad and a root, and you lose the control pad, and suddenly you're back out to playing around with yet more bits of routing Max messages, which isn't something that Max does particularly well anyway. It's always messy, isn't it? So these are the things I disliked about Max, and maybe you dislike them as well, I don't know. But that's what I disliked about Max. So instead, I've played with a couple of things. I've tried Super Collider, C-Sound, and stuff like that, and somebody suggested to me to try ChucK. So I thought I would, just for fun. I noticed that not many people use it at all, so it seemed an even better choice. It's always nice to look at something that nobody else is looking at. Kind of separates you out. So the kind of key features that they sort of boast about with ChucK, and then I'll add you my own kind of informal thoughts, is it's what's called strongly timed. ChucK is all about time. All we do in ChucK is manipulate time. We set up a DSP system and then tell it to do something for a certain period of time. And that's basically the undermining premise of ChucK in its entirety. It's really simple, and it's just like that. It's object-orientated, which for people who know me will find quite funny, because I hate object-orientated programming. I consider it to be the devil's work. I'd strongly recommend avoiding it in all possible ways.
I wrote for that as well.
Oh, there you are, yes. So there we go. It's quite funny that I really enjoy ChucK and it's object oriented. It runs in Linux, OS X, Windows. It's open source. It's on a BSD license. If anybody's got an iPhone, the kind of Smule apps, sort of the Leaf Trombone and the Orica and the stuff, are all running a kind of custom build of ChucK as the DSP processing that you're kind of playing with. So if anybody's, you can't actually touch that. It's not something you can hack yourself because it's a commercial company, but it's nonetheless part of the BSD there.
By the same guy.
Yeah, by the same guy. One half my code license, the other half the other way. So stuff. They claim it's a new design. I don't agree with that entirely. It definitely borrows from other languages. If you've got some familiarity with C and stuff like that, you're going to spot kind of those kind of similarities straight away. The big thing with ChucK is it's, as alluded to, it's very dirty. So things that you should do, if you look at a piece of code and think, in C I should do this, this, and this, there's a good chance in ChucK you can throw away 3 or 4 of those steps and it'll probably work anyway. So let's go. I'll move on to my 2 favourite features of ChucK though. First of all, it's incredibly buggy and it does all sorts of crazy stuff all the time, which is great. It's just a consequence of being able, you'll find that, I'm not sure if any of my examples today, actually no, I have one example which will do it, but there's times where it's so buggy that you have to kind of force it to do things it won't do, but I know they'll work, but it's not convinced they'll work itself, so it just tells you it's a fault. So you have to kind of, it's something you kind of definitely get to know more and more. It's almost like an instrument. You really get to know what sounds good on it and what doesn't sound good and how far you can push certain things. The other thing is, in the exact opposite to Alex's quest for more and more and more efficiency, ChucK is horrifically inefficient at all times, and there's just no way around it. That's all there is to it. There's no way around it. It's great, but there is no way around it, and I'll show you some of the reasons why it becomes really inefficient really, really quickly. It allows you to do completely crazy things which are probably very limited creative use and probably are a lot easier to do in other ways and more efficient in other ways, but nonetheless it's really easy to do and it's kind of fun to play with. So ChucK's definitely, if you fancy getting really, really wound up with something, but it not looking horrifically messy, ChucK's probably a good option, I suggest. If you want something that's actually going to allow you to get on with your creative life, then there's maybe another language for you out there. So, as I've said, chucking is I hope you like my kind of titles. They run out pretty soon, so you better smoke them up now. But chucking, it's based around time, and it's going crazy on here. And we manipulate time using the concept of this idea of now. So now is the point in time that the virtual machine, which I'll introduce in a minute, thinks it's at, but it's also us telling it to process, to go on to this point. So when we're chuck a time to now, a period of time or a duration of time, and maybe a second, 2 seconds, a day, a week, and then ChucK will continue to go on until that period of time has passed. So that's that. Luckily, it can run simultaneous pieces of code at the same time, so we don't have to wait for it to do something for a day and then to do something else for a little period of time. So that's that. As a consequence of that, we have duration, DUR, and time are both classified as native types. So they're things that ChucK actually understands and works with, sort of style. So you don't have to think of time, whereas in something like Max, we're always having, we might have a number box which has 100,000 in it, and that's milliseconds, but we know that's 100,000 milliseconds, but to the computer it's just 100,000 as an integer. Whereas in ChucK, we actually declare a duration or a time against a unit that we would actually understand ourselves. So you can see them here as sample, millisecond, second, minute, hour, day, week. Rumour has it that month and year work as well, but obviously I've never bothered to try that. But if you want to, you could try it yourself.
Well, that implies you've tried week.
I've tried week, yes. I have tried week, and week does work. It's obviously pointless, but it does work. Well, if you want something really crazy. What's really cool, which they don't really talk about, and you'll start to get the kind of feel as to why ChucK is really inefficient and really problematic, is that it works happily with fractions of these units as well. Now, a fraction of a second is obviously a millisecond, but we can get down to fractions of samples, at which point it starts to try and do kind of crazy interpolation between the samples that actually exist and stuff like that. And that's where it falls apart very, very quickly. But I'll show you it falling apart for fun when we get there. Because it is fun, but it falls apart. I should also note here, it's something I'll talk about at the very end, but it also has an inbuilt system called events. And events is about manipulating the outside, interfacing with the outside world. So things like MIDI devices, OSC, the accelerometer, eyesight, any sort of data like that can be pulled in and is manipulated using the event system, which I'll talk about at the very end. So that's the kind of additional way. If you don't want to move something with a fixed period of time, you can move it on the basis of when this happens, it's now, kind of as an idea. We'll see when we get to that. So as always, we'll have our obligatory sine wave, if that's okay with everybody. It's
hello world.
It's always good to sine wave our way to everything. So this is our sine wave in ChucK. I'll just try and pull up some bits. So this window here is the virtual machine. ChucK runs a virtual machine as a thread. And then you have, I'm using the mini article, but basically you could use any text editor and the terminal and just throw stuff along through the terminal interface if you want to. It looks messy, and I think this is quite neat and tight. Down here we have the console monitor, which is where our first indications that things are going wrong will momentarily appear before it crashes on us, which is always nice. And we'll be aware of that. One of the greatest features of ChucK is because it has the, in the same way that SuperCollider has that separation between server and client, the ChucK virtual machine runs by itself, so it's possible to hang the virtual machine and not the user interface, or hang the user interface and leave the virtual machine running. So you can get ChucK code which will just run, and you end up having to close your laptop down and stop it or pull the battery out, which is kind of annoying. But I've done that a few times. It's hard work, but it's kind of fun when it gets there. So anyway, we'll see how our sine wave is today.
You need to learn kill in terminal.
Well, yes, that's the other thing. So we just start the virtual machine. As I've said, it's all about time, and you'll see that the virtual machine's already tracking how much time has passed. So we're good in that respect. Let's have a little bit of volume maybe. Maybe not that much. This one. ChucK's also really loud. It's kind of weird, but that's kind of. There we go. So that's our that's a sine wave.
For a second.
For a second. So we got 1,000 milliseconds. I use a millisecond because it's less keystrokes than typing a second would be, and as you do that more and more, so I just like to do everything in milliseconds. At the top here is our DSP. So if you imagine the very first line here is the representation of the DSP. It borrows, again from SuperCollider, the idea of there being a UGen, which is a base object which does some DSP processing. In this case I'm using the UGen, which is called SineOs, which gives me a sine wave oscillator. I give it a reference called S, which is just my way of interfacing with that object and that instance of that object. And then I'm using what's called here the ChucK operator. One of the greatest things about ChucK in its dirty habits is it basically has 3 operators and you can do everything with them. So the first thing you try is the ChucK operator, and if that doesn't work, you could try one of the other 2. But 9 times out of 10, the ChucK operator does absolutely everything. So you don't have to worry about complex kind of getting the right patch codes to the right places and stuff. You can just start to just use the ChucK operator. You'll see me kind of throwing these bits together. Finally, I have the DAC here, which is just the digital audio converter, which we're familiar with from the language inside MSP. So it's down. Semicolons ending the line. So that is my DSP processing. That's everything that gives me the sine wave. And at the bottom here, I'm just telling the code to run for 1,000 milliseconds. And as a consequence of having a sine wave oscillator plugged, chucked into the DAC, when I hit go, it plays me a sine wave for a second. If I wanted to, I could also change it, have 2,000 in there. And now plays it for a little bit longer. So for me, one of the really interesting things about ChucK is the fact that this is how we manipulate in time. This is, we manipulate time in ChucK. It's really, really simple and easy to do, whereas that kind of thing in Max, we could do it, couldn't we? But we'd have like a metro object perhaps, or a line doing some sort of stuff. And you can probably imagine how that bit of code would be quite a bit bigger inside Max straight away. So this is definitely one of the strengths of it. So if I just leave this example behind for a minute, here we go. Let's say goodbye to that one there. So thinking in time is definitely musical, and it's Chuckian, as I say. It's and it is like music is a time-based event generally. We think of it in time, the progression of time in various bits and sections and such, and we can look at that. I mentioned I talked kind of in detail about the idea of there being time and duration, but we can also make durations up that make sense in a musical way. So we could declare a duration of a beat and a bar, and then use those durations to drive the time forward. So as a consequence, we could turn around and say, rather than having 80 beats per minute, I'd like to have 90 beats per minute, put in, and then use that to actually drive it forward. So we could have the tempo entirely driven by those kind of very musical decisions that would make sense in comparison to a score, rather than having, so the idea of there being a beat in ChucK is quite easy to kind of put together and code together in a way you can read it as a beat. rather than having some period of time kind of flying around that may or may not make sense, or having Max doing something with metronomes and line objects to kind of give this sort of impression of it being. So I think we're have a little ChucK tune here. This is a, here we go. So it's gonna be classic. I hope we enjoy it. I don't think it's anything particular. There we go. So that's how about that? It's awesome. This is the level I'm leaving the VM running at the moment, so I got to be kind of basic with my code, otherwise it starts to die a lot quicker. So again, you see we've just got the UGen at the top here for the DSP processing. On this line here, I'm sending a frequency. I'm setting the frequency of the oscillator S. So you'll notice I'm using the ChucK operator again. So I just chuck the number 440 to s.frequency, and frequency is the variable for the UGen there. So now I get a frequency of 440 hertz. That's all put together for me there. Obviously, I'm putting time forward by a second, 1,000 milliseconds to now. At this point here, ChucK has a massive kind of standard library of musical functions. So here I've got a MIDI to frequency. So I give it a MIDI note, and it's now going to send me out a frequency, which I can just throw to s.frequency. So I'm just kind of using that to show the standard library features. The standard library is huge and does a whole load of stuff, and I'm not going to talk about it any more than that really.
How is it easy to access like help files? So you're coding Synapse and you want to know all the different instance
Oh, that
variables.
doesn't exist.
That doesn't exist.
No. That
So
doesn't
you don't know the instance variable of Synapse.
HTML on the site?
Yeah, there is an integrated system, but there is a very good PDF reference. There is a PDF reference file which is as good as the Max reference, but it does have all the bits done. It's very good. You can look at it and kind of pick your way through it, and it shows you all the various parameters they have. But there's nothing integrated into the environment at all. So
yeah,
I can't
the PDF is searchable, so it's easy.
Yeah.
It's easy to go.
So then I could, I'll have the PDF. I could show you the PDF,
Yeah.
but then if you want to. But it is easy to kind of jump to it, and it has it all sort of listed. And trying to think, in December we re-edited the PDF, and we're building a brand new version of it, which is even kind of better now. And we've redone all the tutorials to include some new stuff, so it's a lot neater and easier to follow through, hopefully. But I hope what you can take away from there is obviously it clicks horribly, but and at the end it clicks nicely. That's because I obviously haven't made any consideration for that whatsoever. I could do, and maybe we'll come back to that if it's of interest to people. But what I'm hoping you're taking away is the fact that I've got something which looks like a score almost immediately here. You can see, a pitch and is a pitch for a certain duration. That's very much like a notated score. You can probably see how we can start to pull these things kind of come together quite nicely in a very neat way, which is kind of cool. Okay, so we'll leave our number one smash hit behind and move into the next one. So this is where we start to get into some of the issues with ChucK, because I've just been showing really basic kind of little bits of code because I know they'll run and not crash, which is nice. But the whole idea of ChucK is it offers this kind of sample accurate synchronization across anything you're doing. So when you put stuff into the VM, into the virtual machine is sample accurate the whole time. Now, I talked about being able to use sub-sample lengths of time, which is where it starts to get a little bit crazy. My interest in ChucK is in real time, and you can run it in non-real time, in which case it does it all a lot better, but I'm not interested in non-real time, that just bores me. So there we go. I don't know much more about it other than it exists and it's meant to be a little bit more reliable. So let's start like that. As part of the ChucK, as part of the virtual machine, we have the we have what's called the scheduler, which is in charge of making sure that all the shreds that we add into the ChucK, add into the virtual machine, are all running at the same time, are all stable, and are kind of keep on going. And it's designed to pick it up when one of them stops working and tell you about it, which it probably will show us at some point. So when we get to there, I'll draw that to your attention again. But the great thing about concurrency is that we gain it by sporking out functions. So I introduced Max as a object-oriented programming language, and immediately we've now gone back to functions. Yes, it's like that. In its defense, we can spork object behaviors. So it's kind of we kind of can do it, but it's there. One of the really neat things about it though is that we can manipulate the control rate that we want all of these bits of code to operate at. So I can have one piece of code which is doing something every week, and another piece of code which is doing something every sample. Put the two of them together and they'll stick together exactly, even though they're running at very different lengths of time. So that gives us the opportunity to gain a whole load of, you can gain some efficiency by picking an appropriate, duration of time if you want to. And at the same point, you can go ridiculous and have things at a very kind of fine level, all running in the same sort of place without having to make particular considerations as to whether it works or doesn't work in that situation. So I think, if my memory serves me correctly, we're going to have some LFO here now. That's it. Yeah, there we go. So here we've got a little bit, this is probably worth pausing a little bit longer to look at here. I'm going to stop the VM because we're just starting the edge on the side. So obviously at the top here we've got another sine wave going in S stack. Next down here I've got another sine oscillator, this time referenced as L. You could reference it whatever you want, I've just used L. And this is being chucked to something called the black hole. Now, the thing with the UGens in ChucK is that they don't do something unless they're plugged in together, unless they're plugged into each other. And at the very end of it all, you need to pull it into either the DAC or into what's called the black hole, and the black hole is basically the DAC without being connected to any of the actual physical outputs. So it's down. So you need to pull it through there. Now the great advantage of that is I can write a whole load of DSP code at the top of my ChucK file, and if I don't need it, unless a certain situation comes about, then I don't actually use it in any way whatsoever, and it'll just sit there completely dormant at no cost whatsoever, other than I have a slightly larger file to save. And it's only when I actually try and use some of that code I can, when I try and use it, I can say, right, I want to chuck this together now, and I can dynamically chuck it together, and then I kind of build that bit of DSP together. So I suppose in comparison to Max and Max MSP, whereas, if you build the MSP, when you build all the MSP, it's all running and it's all there unless you start to use the kind of various bits of objects that kind of bodge that out. So it's that, whereas with this, I can actually design it not to include it at all. So if we just skip this middle bit for one moment, you'll notice what we've already seen here, which is my kind of, a basic sort of score. I'm just throwing a frequency into my main oscillator at a period of time's passing and such. So I'll come and have a look up here at our function. So I'm just declaring a function void, calling it LFO. I'm not passing any arguments into it. I'm not taking any arguments out of it. So it's as it is there. I'm using something you end up using a lot in ChucK, because while being able to tell something to happen over a day or a week, more often than not, you just want to tell it to continuously happen over and over again. So to achieve that, we can just use while and a 1. While and a 1 is the argument. So while the while loop is 1 equals 1, it will go forever, and that's it. So with the number 1 in there, it's only ever going to go forever. So within there, I got a couple of bits of code which, maybe we should play this first actually. So we get a little bit of, so I can just kill off the sport for a minute if you want. So we're just getting a little bit of modulation on it there. Now if you have a look in the code, I don't know how readable people find it or not straight away, but s.frequency we've came across. Previously I was chucking a value to it. In this situation I'm taking the value from it, so I just call the function s.frequency, so I just put 2 brackets at the end of it. Now s.frequency gives me the value that it currently has, which was a value I've set to it, or it's whatever value it's currently been working with. Next along here I've got l.last, and this is where we kind of get into some of the real cool kind of stuff inside ChucK. L. is the sine wave oscillator we've got declared up here, and l.last is the very last sample it generated, sort of stuff. Now that sample's based on the period of time that I'm working within. So at the moment I'm working with 1 millisecond here, because that's my period of time I'm asking this loop to go over. So to give me the last sample that L generated a millisecond, every millisecond as it goes on, sort of style. Now it's always 1 sample behind, obviously. So we're immediately gaining some latency here because we're a sample, but there we go. It's just how it is. You'll notice here I'm timesing it by 10 just because that's basically me just increasing the depth of the modulation. That's all that value's doing. That's the reason there. And you'll notice that finally I'm just chucking it to s.frequency. So, you can probably see how that piece of code is just working for it. And finally it's going around once every millisecond, so we get this kind of thing. It's kind of fun. If we wanted to, we could just start to manipulate the time. In many ways with ChucK, once you've got a piece of code working like this, it's as easy to manipulate the period of time it's working on in terms of control as it is to try and manipulate more detailed parts of it. So we can have this kind of silly thing there. It started to disappear as we got it. I suppose what you're wanting to see is maybe this sort of language in use. There we go. It's nice. The one that you're really all holding out is probably for this one. There we go. Nice. I'll turn the volume down. You're kind of keen to hear this one. There we go. Yeah, that's nice. We all like that one very much. Come on. Oh, there we go.
Oh.
That died. You can, if you see, the time's actually slowing now. We're in some time. There we go. That was ace. This one shouldn't work at all. Let's see. This is the one where I'll kill the computer. Oh no! Oh no! It's there, but it's. There we go. Yeah, no, it is. It is entirely. You'll notice that your time is actually stationary right now.
It's like when you run like too many plugins and then you do duplication, you lose a sample. In this case, it's just spitting sometimes samples when you're not too overwhelmed by the math.
Yeah, if I ran this in non-real time, it would actually
make
the right thing. But it's kind of fun in terms of doing this. And if you're at the performance I did, I actually used its inability to keep up to just kind of filter out the entire sound of what was going on, which is kind of fun and creative effect.
Use a week.
Use a week, yeah. I don't think we're going to be here for it. We don't want a week of that, I don't think.
Can I ask a question?
Yeah, of course,
already, because what I don't understand is the relation between the modulating frequency. You're polling an oscillator that doesn't oscillate, therefore. Is that what
our default frequency?
The
sine oscillator L, what's the frequency? Because you haven't.
What's the frequency of L exactly?
Has it just been?
No, the frequency of L's here, 80 to L frequency. That's the frequency of that. So if I wanted to,
in non-time, exactly. Thank you.
So I could do this kind of thing up here as well, if I wanted to.
So the 1 millisecond is just the control rate.
That's the control rate, yeah.
Okay.
But
so you could put it you could have like sample and hold value if you put it to 100 milliseconds.
Yeah, or we could go up to a second and have it do.
No, but that don't work. If you put it like 250, we should hear it because.
Okay. Here we go. But it gives you an incredibly powerful kind of. Gives you an incredibly powerful sort of synthesis options because of the fact you can manipulate these variables all at the same sort of time, which is really kind of neat and tidy. Now, the one thing you may have noticed, if you watch in the virtual machine here, you'll see that I'm actually generating 2 shreds now. One of them is called ex3.ck, which is the file I'm loading. But the other one is the shred that represents this spork that I have here. Now, the spork, as I said, is basically just starting off another piece of code which is sample accurate. They have a parent-child relationship, but it only goes from the parent to the child. So I can declare stuff within the child which isn't accessible to the parent code, but if I declare stuff within the parent, it's accessible to the child, which is, if you think about it, that's a really neat separation which makes an awful lot of sense, and it's the kind of thing that becomes infuriating in Max. Because that would be the equivalent of Max of having an abstraction which can't interfere with anything above it, sort of style. So the abstraction can talk to itself and the parent can send things to the abstraction, but the abstraction can't throw things randomly back up. You have to take the content out of the abstraction as you want to, sort of style. So I think that's kind of neat, and that's the kind of behavior that I probably really like in Max, sort of style. The kind of, something that's maybe, actually it might be useful, if I just add another while loop here really quickly, I'm hopeful my time will hold out for this. If I just, so now what I've got is a while loop running around my little score, which should just keep it going forever and ever. Yeah, it seems like it's gone there. There we go. But the great thing we can do here is we could kill off we can actually kill off the elements, the sporked elements within it, and it just carries on anyway. So I've now killed off my kind of low frequency modulator.
Can you restart the spork?
Yeah, can you restart the spork independently?
I can't restart the spork within this element of code because I can't create. The parent has to spork the code for them to relate to each other.
Is that how it deals with concurrency? Because you have to put everything up at the same time, and that's the way it keeps things separate. Because obviously
for now, yes, but in a moment I'll show you the other way of doing it. But the basic version of it is in this kind of element of code, and this is ChucK sort of stuff. In a minute I'll show the kind of more hacky versions. You're not loving it. So it's not. But I hope you can see how this kind of stuff comes together. And the other things we can do is we can spork as much out as we want to. So while here I'm just controlling the frequency, I could have another spork which would control the gain, maybe of the amplitude of it, and have all these 2 bits running. They can have different control rates if I want to as well. And you know what I mean, I can pull all those elements of code together. Now if you wanted to write something in ChucK, if you wanted to write some sort of synthesis music, then ChucK is absolutely brilliant for it and this kind of thing. It does it really, really neat and tidy. Yeah?
Can you control do all the sporks have to happen at the same time? Can you say this spork starts now, this spork starts in 10 seconds, this spork starts in 15, from within the one file?
Yeah, so at the moment my spork's up here, but if I was to, well, we can see this here, like if I add the spork to,
The second instance.
yeah, so now it's going to play this code once and then it's going to spork.
Yeah.
Now we're going to get a problem pretty quick, but I can show you it working and then I'll have to kill it. So there we go, we've introduced it. Now you'll see it will,
Add another one.
it's now adding more and more sporks. So it's that, which is kind of cool. And it kind of adds these bits together.
But you've got conditional state.
Yeah.
You've got all your if statements and everything in there.
Yeah, no, I could put, we could code that so it doesn't add another one. It's kind of fun letting it add other ones anyway though, and it's the kind of thing it does well. For the people who are purely computer science orientated and like to know about these kind of things, ChucK has a garbage collector which serves no purpose whatsoever and doesn't work in the slightest. It's very much like the level. It's very much like the level of bin service we've seen in the last couple of weeks.
So
Everything that goes up is leak.
It just leaks, yeah, forever and ever. Which is part of the reason why if you can get ChucK to run for more than 10 minutes, which is why.
Yeah, that's why you stuffed
Which is
it.
why, yeah.
Exactly.
You can get ChucK to run for more than 10 minutes after you've been playing with it. You're doing well because it does literally just
run out,
leak and leak and leak. Yeah,
leak.
and that's something that is being fixed, and it is the main limitation. It's why ChucK appears so buggy is because of the fact it just balloons and balloons and eventually dies. So it's kind of like when you start it, you know it's going to die at some point. You just have to enjoy the excitement of not knowing
It's like
why.
all of us. It's really good. When you get, you're gonna die at one point as well. No, the thing is, the spork thing reminds me of the kind of a control sim you could do in Super Collider. But the elegant thing with that is that you've got controlled buses in Super Collider that you can hack, and then you kill the control sim, you remap it or whatever. Can you do that in this lovely code?
Yeah, let's go to that.
Yeah,
We'll
thank
have this
you
sort of
very
stuff.
much.
Okay, so let's say goodbye to.
Example
to that bit
number
here.
3.
Example number 3. Goodbye. There we go. So so just as a quick kind of sketch through here, the really key thing about ChucK, from my point of view, is the fact that it's a text interface. Now, I don't know how people feel about text interfaces, but I'm guessing the general consensus is they're scary and horrible, which is an opinion that I probably shared. Well, I shared at some point, and I'd probably still suggest, Max is a really great way of doing audio programming without having to do programming
For real.
for a bit, and then you hit all the problems, and then you sort of
Text
realize
in boxes without the brackets. I mean, that's what Scott Wilson always said.
it's true, but
Yeah,
you have the
but
patch
come
cord
on.
thing, isn't it? The patch cord thing is, if you think when you look at if I have a Max patch and it doesn't work, the first thing I look for is the patch cord that goes to the wrong place. That's always that's one of the first big problems, isn't it? And it's just the whole kind of interface. So with ChucK and text, you don't have that. It also encourages you to make this separation. So I could have my DSP code, anywhere lying around lying around my page, and when it gets to that point in time, it'll build that piece of code. But if I'm going to use it from the beginning, I can just put it on line 1 or the first couple of lines, and as a convention, you can get this really neat. This is my audio DSP, and now I have the stuff manipulating it, which
sounds like CSAM.
Well, yes, no, it is.
It's all music files.
Yeah, no, it definitely doesn't it? But it gives you this simple to read, I don't have to it doesn't look horrifically messy. It might be long-winded, but it's not horrifically messy. You could work your way slowly down it, and it's linear down the page, time goes down the page. Less messy, I'm just being antagonistic there, sorry about that. It's easier to adapt. I'm saying you saw me just kind of changing values inside the code there and adding it up. I could add the same piece of code lots and lots of times with different numbers in there, and it starts to do that, and I can just type those numbers in as I want to here. I don't have to worry about going into patching mode to sort it out or all these kind of bits, and all the code's there. Like the one thing I was never a big fan of presentation mode or hide on lock in terms of hiding away what's going on and your ability to manipulate what's going on, and at the same point they're very necessary to make it usable, but I was never a big fan of the way you hide away your sort of what you're doing there. So anyway, so beyond some synthesis, and this is really where ChucK was never, I'm not particularly sure was meant to go actually at some point. It's certainly gone there now though. I built something that I call CHIP, which is the ChucK Instrument Processing. It's ace. I'll show you in a minute. And it allows you to manipulate audio with ChucK. Now, it's possible to manipulate audio with ChucK in a, well, it's theoretically possible to manipulate audio in ChucK in a really hard work way, because using .last, you could have an ADC and use .last on an ADC to always give you the sample that just came out of it, and then you could start to hammer sample by sample if you wanted to. That's incredibly hard work. Instead, there's a whole load of UGens which give us basic behaviors, delay, reverberators, chorusing, pitch shifting, that sort of stuff. Much easier to use, so that's what I'm going to demonstrate the use there. So I'm using those object uses. It has, I have a modular abstract design. It's the kind of thing I like to build in Max, which is why I try to build it in here. It also has a graphical user interface, woohoo, built within ChucK. It only works inside OS X. It only works when you're running the MIDI article. It isn't actually built into the ChucK language. It's this kind of add-on on the side of it. So I think we'll have a look at CHIP. Now,
is it Fry in America?
So let's give it a quick open up here. So the chip code starts to get a little bit more. It starts to get a little bit more verbose at this point here. You see I've got my nice little interface here, which kind of looks very OS X-y. That's kind of nice. We're coming to have a look at this bit of code in a minute.
It's a good pun, actually.
Yeah, you like what I did there? That's cool. So, obviously you can tell my Max heritage, because I have a tendency to refer to things as patch still. So what I've got here is this is my sort of layout for, let's say, this performance. Now, another bit that's broken inside Max is dependencies, so I have to manually load my dependencies before I can load them. So if you give me a minute here, this is my multi-tap delay. ChucK, sorry.
You've got like
so there we go. This is a multi-tap delay that I just added, which is that one there. I need a chorus.
Very simple to have a GUI, eh?
There's chorus up there, and
so you just have to.
I'm just ignoring you. Pitch shift. Did it go? Oh, it didn't open the thing. Just check. So, I've loaded these elements in. When I say the dependency system doesn't work, it does, but the file paths are absolute, so it doesn't.
It's always absolute.
It's always absolute file path. There might be, but I don't care that much. Basically, that's not true. No, I have a cheat approach. If I build a disk image inside disk utility on OS X, and then it's relative to then I can go from the volumes up. Yeah. And that works really well if I need to do this at speed. But I don't care about that kind of thing. So, to me, I can set this up and find it's alright. So now, with a little bit of luck, where I either get a whole lot of errors or it works. It worked. There we go. So now we got maybe I should have another one here. If you look in the top of the windows, you can see their relation, you can see their directions between each other. If I grab iTunes, hopefully if Soundflower is working properly, I'll get some audio from it. And we can push it down to the top. There we go, something random. Case Choice, they're a great band, but we might hear a little bit of them in a minute if it's working. So we have a look here, there we go. So I've got a little, this is my volume, my amplitude meter just showing me I've got a volume control here. It kind of works. The meter more tells you there's audio there rather than what the volume of the audio actually is. Just so you're aware. But it's the amplitude's times by 1,000 because I like the reassurance of it actually flashing. I can use my ears to tell whether I want it to be louder or quieter. So I like to see that. You'll see that I got this kind of coming in here. So I'm just going to chuck some values across to this bit here. I got this is my bus delay. There we go. There we are. Right, just a couple of delays. Maybe change the delay time. You notice it does crazy little things every now and again for numbers. We just ignore that and click once and they go away. There we go. A little bit of feedback there.
Little bit. So we're there for
these meters will eventually start to do things, which is cool. There we go. So now we're on to bus 2. Bus 2. So I just put some volume out there. Now I'm just showing 3 of the most stable bits I've built, but obviously I don't need to use all these. I'm just using them for fun. Here. So that's the kind of audio we put together. Nice. There's obviously a leak somewhere there. I'm reading some memory somewhere. So this is kind of my ChucK, kind of some instrument processing here. I could obviously with a huge delay unit, it's just going to cause absolute chaos. in the back there, so I'll just kill it down from it. What's more interesting, and the reason why I'm showing this, is in terms of what the code itself is letting us do. So if we ignore that for a minute and just look at ChucK itself, we'll see how long this runs before crashing. But the cool thing we can do is the virtual machine has the ability, we can declare static portions of memory inside the virtual machine. And once we declare the static element of memory, now we're not really meant to be able to do this, but because the garbage collection doesn't work, once you declare a point in memory, it doesn't change because nothing disappears from beforehand. So it's a kind of nice plus point of a terrible situation. Again. So,
It'll break as soon as you fix it.
well, this is interesting because, yeah, it'll break if they fix it, but it's really cool that we can do this, and nobody wants to write the piece of code that would keep this working after it gets fixed. So I kind of wonder if ChucK will ever get fixed. Because, you know, we can just buy a computer with 8 gig of RAM, it'll be fine. You know, I'll get 20
Well, we're going
minutes now.
64-bit.
I'll get 20 minutes there, don't I? Nice. Let's face it, you know, if you're going to a ChucK concert and you're guaranteed nothing's going to be more than 10 minutes long, it's not necessarily a bad thing.
That's a good thing.
Not necessarily a bad thing. Anyway, so what we've got here is I've got a public class, I've called it bus. Because it's a public class, I'm declaring it. It's now VM wide. I'm only allowed one per file because the file linkage doesn't work properly, as we've already discussed. But that means we just have to add lots of files. You'll see me do this in a minute for the events. Inside there, I'm declaring a static point, gain, a static UGen called gain. I'm giving it a reference, which I'm going to refer to it using @channel. I'm using some arrays here because I want 4 of them, so I've got @channel 4. So I've got an array. I've built an array of 4 points in memory that I'm referring, which represent the gain UGens, and I'm calling them chan4. At this point here, ChucK panics because you're not allowed to declare non-primitive types inside public classes. Goodness knows why, it just never got built. So as a consequence of that, we have a little hack at the bottom here, which allows me to declare a new point of reference in the memory outside of the public class, which is the point that I can actually use to use it, which is what the basis of this line is here. So if it was kind of fixed properly, we wouldn't need this line, which would be nice, but for now we need this line, so it exists, fenced out. But as a consequence of that, it means that I now have bus.channel square bracket 0, bus.channel square bracket 1, bus.channel square bracket 2, bus.channel square bracket 3. And they are just literally, I'm just pushing the audio to these points of memory as I want to, and I can pick them up from this point of memory again. So if you noticed at the top of the top of these windows here are bus.chan0, and I'm just chucking it in. That's just a representation of what's going on, but you can see I'm taking the audio from bus.chan0 and pushing it between the bits.
What is ADC chucking imply for? I don't understand this. The 12, 13, yeah.
No, it's a chain of buses.
Well, what's happening here is I'm putting the audio, so this is the audio input, which is just coming from Soundflower and inside my Mac, but it could be a sound card obviously.
Yeah.
And I'm putting this to bus.channel0. Now the reason that black hole has to be there is because the UGens don't do anything unless they're connected to the black hole.
Okay.
Well, unless they're connected to some sort of sound card coming out. So if I want the ability to see the meters move before I put audio out of the system, I have to put the black holes in place, otherwise I just have to connect it all up to the DAC to put it all the way through.
4 buses, and when you instantiate it like this, you go ADC in bus 0, and then 1, 2, 3 don't have anything in it.
Yeah, but that's only because of the fact that I've hard-coded ADC to bus 0.
Yeah.
There's no need to have that. And I can have as many buses as I can have system memory that I can cope with killing.
Yep.
So 4 is quite stable for about 20 minutes, 8 stable for about 10 minutes, and you know, the more you get, the less stable it becomes, sort of stuff. So it's kind of quite messy in that sort of respect. The rest of this is literally just the meters and the sliders that you saw, but it's classic kind of interface building using for loops to iterate across elements of code over and over again and just position them around. And it's kind of dirty and horrible and not very much fun, but you have to do that. You'll notice at the very bottom, just to prove that ChucK's all about time, if I want this to exist, to be actually used, I have to tell it to exist for a period of time. So I'm telling my public class to, you know, because I'm declaring the public class, but then using it all in the same place. If I want this stuff to continue to actually be there and work and operate, I have to allow time to pass. So I'm letting it have an hour of time pass. And, yeah,
Can you programmatically get rid of things? So can you just make that ridiculously long?
Yeah, I can do, but the problem with killing stuff is that the garbage collection doesn't work, so there isn't any benefit to... It's actually better to leave stuff there and disconnect it on the chance that you might reuse it rather than kill it completely, because you lose the ability to use it, but you don't actually gain the memory base that you've actually exploited further.
Is it an arbitrary value, the hour down there? Would it make a difference if that was a minute or a second?
If I put a minute, this would die after a minute. It would just, this piece of code here.
But because it's on a
would
while
disappear.
loop, does it not just then restart?
Well, yeah, I'm saying it would go round and round, but the 1 hour means it doesn't, you're essentially deprioritizing the timekeeping of this
Yeah.
piece
And
of
what
code.
you would do if you do that is that every minute it would create a new set of 4 buses because the garage condition doesn't work.
Yeah,
So
but it's
add
only
buses
iterating
and-
around this bottom part of the code because it's time-based, so everything above here has happened,
Oh.
and
okay.
now it's just doing this last
Oh,
bit
this
here.
is just stopping it from.
This is once, and then it's just like
Yeah.
existing for the fun of it.
So that's yeah, I think it's probably, yeah. So you can see it's spooking out here, so the monitor that we're seeing for the amplitude is level 1 here, and the slider event, which I'll talk about in a minute, is the events, is when I move a slider I cause an event which changes the gain on the
Five
new
to
gen.
finish.
We've got 5 finished. Alright, so I'm going to go quickly here. I'll have to go really quickly because the first thing I'm going to have to do is kill ChucK completely because we've got no chance of recovering from that mess. There we go. Goodbye, ChucK. 1 minute. There we are. Excellent stuff. So just while that, we'll let the OS try and tidy things up for us a little bit. So the final kind of cool thing about ChucK is using events. Now in the same way that we can pass audio between shreds by using that sort of hacking, we can also hack the event structure to cease to be within shreds and become global as well. Now I said at the beginning how the thing that annoyed me about Max was the fact that things were always global. So the great thing about ChucK is things aren't global, but you can make them global if you want to, which is nice because then you can, you've probably seen how we could build 5 or 6 little synthesizers and then have a score and have the score sending events which will trigger off the little synthesizers to do little bits, and that gives us a really nice separation between this is my DSP which makes the sound and this is my score which actually is what I'm playing, and then I could swap out the score for another piece using the same, I don't know, orchestra of synthesis maybe, I don't know. So it's a method of driving now, can be global, it can be extended, which I'll show if we get enough time. It basically, the event structure is used by MIDI. MIDI extends the event structure, as does OS, the Open Sound Control extends the event structure. So once the event structure is running, if you want to turn an event from being within the code to being external to a MIDI device, it's just a matter of creating the MIDI device input and then linking the 2 elements together. So I'm not going to show those bits because it just involves various bits. So apparently we're having a ChucK party now. Let's go on over here, let's have a look. Oh, we've got an extra example which isn't in here. So this is, the first thing we're going to see here is the problem that I can't add, well, actually it's not too bad this one because I've only got 1 public class, so I could run this all as 1 piece of code, but to illustrate what's going on, it's easier to run it as bits. So I'll just pull these strings out here. So the first thing I've got here is my, I'm making a public class called E. Is that going to run? Yes, it will. That's all right, cool. And I'm making a static event because an event isn't a primitive type. I'm not allowed to declare it inside a public class. So inside a public class, so as a consequence, I've got my line at the bottom here, which just gives me the references. If you want to have a look at that, I can send you to the page of documentation that tells you about it. But we can just add that. You see that nothing's happened, other than at the bottom it's told me it's spoke the incoming shred 1. Nothing has actually appeared inside the virtual machine at all because I'm not doing anything with this code. I'm not running any time. I've just added a public class which I can now exploit. So if we get here, we can get the wait for event. So we'll do it the wrong way around for a minute. So if we just add this in here, I'll just quickly add this piece of code in. We should see a shred. Oh, great. There we are. That's all right. Just put that into a string. There we are. That'll do. There we go. So now we've got a shred running. It's untitled again. We can see it kind of went in. It gave me my error message. Nothing's actually happening at the moment at all, though. All this piece of code is doing is waiting for this global event e.sw. I use this, it's a notation that I like, which is just, I use capital E as event, and then SW for me just means system-wide, because it's system-wide, but it doesn't matter, it's basically matched up to the text I've declared here. Closed down so you can see where that's coming from. But this piece of code is basically sitting, if you imagine inside the VM, it's now sitting here waiting for this event to happen so that it can go on to now. So if we grab this final little element of code here, just kill this one off, there we go. If we add this in, you'll now see I've got my 2 shreds going and suddenly my console's now come to life. And the reason the console's come to life is you were probably thinking, man, that's not a real programming language, there's no debugging. Yep, there is debugging. We have one way of debugging. We can dump any value out onto the command line. So here we are, this is the entire debugging available to us in ChucK, is the ability to dump a string or an integer value back. So we can see that the code is actually now progressing we get the word, we get hi, which is from this piece of code here, and it's going around. If I clear this buffer out, it'll start to repopulate again, so you can see it's going round and round and round in circles. So that's a really, that's the event structure in place, and I can run if I run the events within what's going on, I can literally just use event, give it a reference E or whatever I want to, and then just do to now and have a spork that does e.broadcast, and it would do that. But I want the events to operate between shreds, completely separate, non-related shreds, then I have to declare them in this public class way, and it introduces this additional bit of complexity. Now, if the public class issues were resolved, then you would just be able to go back to writing static event e : and that would be it done again. But it's because of the fact we're not allowed to have non-primitive types inside there at the moment. We've got to do it like this. So, do I have time to quickly show the extended version?
No.
Oh, that's harsh.
Yes. I think you've teased us enough. Okay, you got 30 seconds.
30 seconds. All right then. So going really, really quick. This code is basically the same. You see, I was just going for it anyway without you realizing. So if I go really quick, what I'm doing here is I'm extending. It's an object-oriented programming language. It gives me polymorphism. It gives me the ability to extend stuff out. So here I'm extending the default class event, which isn't primitive, with my own class EE. The reason for that is so I can have a. It's gone out of my head. It's not behavior. What's it called?
Instance variable.
Instance variable. There we go. Thank you. Int value, which is in place here. Now I'm going to use my hacky piece of code. This time though, I'm using static EE, which is the name of my class, rather than static event. That's the only difference. I'm just going to add it in lots of files here. My apologies. So now I'm going to add the while code. You'll notice here, while the e.sw is exactly the same, instead of putting hi, I'm going to try and put a number out. So I'm e.sw.value, which is the extended variable. So I'm using the inheritance to give me this. So now there we go. We added that, and with a little bit of luck, I'm using std.rand as another part of the built-in functions, which gives me a random number between 1 and 10. So if we add it, and all's gone well, there we go. We now get a random number passing. We now get a random number appearing as an event passing through the code.
And so any code could tap in the global bus and static global bus and tap that value.
Yep.
So you can sync your instances as sync and whatever with that kind of
stuff. And I could have as many different values of this as I wanted to. The other really neat thing about the code, if we look at the receiving code, you'll notice that the time-driven element is just the event arriving. So I can use e.sw, and that's the equivalent of maybe a max bang. So that's a bang, and I could ignore the fact it has an integer or a float, or it has a collection of integers or a collection of floats attached to it. I could ignore that entirely and just use that to say, this point happened and I'll now do something, but at the same point, if I want to pull the value from there, I can pull the value from there, if I want to as well. I can also just pull the value out at any point I want to as well, so I don't need to have e.sw equals now and then the value. I can pull this value from anywhere anyway. So it's another way of...
With while loop that are auto-synced in synthesizer, you could pull it.
I could pull it like that rather than using the event structure if I wanted to as well.
And can you dynamically change the time in that while loop in this instance?
This one here, you mean?
Yeah.
Yes and no. So at the moment, I can, but not in the way you're probably hoping. But
so you can't just take that value and multiply it by 100 and have that as your now?
Well, yeah, so what I could do is do this kind of thing like this and add 500, and now, so the reception point still exists. Yeah, but that's because I haven't built a static variable to allow me to do it. But if I built a global static variable, I could then link that to the duration and control that variable from outside it.
Cool.
The other thing you could do is like completely non-considered stuff, but I could now run multiple elements of this code, all generating those values in the same way that you can have send and receives being fed and received from multiple places.
One more question, if any.
Yeah, I have one question.
You ask him later. You ask now.
1.5 question.
Okay.
Yeah, go for it.
Well, the first is, all humor aside, is it very buggy? Can you use it from a composer's point of view? Or is it like a work in progress?
No, it's very usable, but you've just got to learn around the bugs, if that makes sense.
But it's quite buggy.
Yeah, but the bugs are absolutely consistent.
Okay.
So,
but it's not as solid as Super Collider.
It's not. I'm maybe giving the wrong impression. The bugginess is it claims to do things, and if you do them the wrong way, it'll just crash and it'll just kill everything dead. And if you're not careful with your manipulation of kind of time, you can get immediate problems, because if you try and get your machine to do too much at the same time, you can overwhelm it and it just dies.
So
and it
you-
doesn't die neatly, it dies.
So if you know what you're doing and know what the bugs are, you can use it for
Yeah.
proper use.
Yeah.
And the question number 1.5 was how does it compare to like C Sounds, Common Lisp Music, and Super Collider? What's the difference really? As a long issue, I guess.
Maybe you can talk about that after.
The main issue is the progression of time. That's what it's about. If you're not interested in progressing things in time, then there's better,
And
you know.
strong time. I mean, that's
It's
what-
a strong
yeah,
time,
that's what
yeah.
it's saying. It's the idea that
Yeah.
you can control it as tightly as you need to, rather than being tied to this idea of a vector, and you're either doing it every sample or once per
Well,
vector.
Yeah, but
there's
Super
thing
Collider.
called Vessel, which is like you program things in Lua, and the thing is there's not many Eugens. There's a library of Eugens that are written in C, but the control structure and the DSP chains are all you write it in Lua, so you can make dynamic. Algorithmically, you can design the DSP chains, for example, and it's sample accurate. So
I think the thing to bear in mind with ChucK is its heritage, because with it being Princeton and they have that kind of heavily integrated computing and music department kind of feel to it, it's a computer science student has essentially solved a whole load of musical programming issues, but it's now become the situation where it's being used by musicians who aren't interested in solving the computer science problems. So, like, I've kind of flippantly joked about these problems, but I know how to work around those problems. So for me, I don't have the time to feel minded to solve the computer science problem. I know how to solve the problem from a musical point of view, and therefore I've shown you kind of 5 or 6 undocumented hacks which allow you to do these various bits, and we're slowly documenting the hacks because we're getting to the point where we're not really interested in the computer science being solved now. We're happy with our hacked systems because we've built, people have invested 2 or 3 years on programming now, and the last thing we want is, if garbage collection comes in and kills all our static Eugen hacks like that, then it's, that's going to be a backward step before it's a forward step sort of style. So
Thank you
it's
very
kind of
much.
interesting. I'm done. Thank you.
now.